Alright, let's move into problem number 19 now. Let's read out the problem. So this problem talks about counting Sundays. So what it is asking from the last century, 12th century, which is 1st January 1901 to 31st of December 2000. Of this 100 years, how many Sundays fell on the first of the month? So it's not asking you to count all the Sundays. It's asking you to count Sundays which was at the first of the month. And another thing you have to note it says 1st Jan of 1900 was Monday, but it is asking you to count from 1st Jan of 1901, not from 1900. So that's what you have to keep in mind. So let's jump into our coding. Let's say problem number 19. Okay, so what we'll do is first I like to create a dictionary of month to day count dictionary. We know that January is 31st, which was explained here. January is 31st, February is 22, but February can become 29, 28 or 29. Then March is 31st and so on. So I like to create a dictionary like that, and let me just copy the dictionary because I don't want to type here. So yeah, so here we got the month day dictionary. For now we have kept 2. Month is 1, day is 31st, month is 2, day is 28. We kept it at as 28, and it can become 29 for some situation, but we'll handle it. And other months are already known. For example, April is 30, May is 31st, 6 is June 30, like that. Now what we would like to do is we like to create a number of days month. Obviously we can get it, but because of February it becomes some more complex. So what we will like to do is we like to create a function get number of days, or is it number of days month. Okay, and here we'd like to pass the month, and we'd like to also pass the year, because depending on the year February can become 28 or 29. Okay, so that's the logic we want to keep. So we just say first of all, if month not equal to 2, that means this is straightforward. I can just return from our dictionary, return month day dictionary of month. So that should be enough. Else, let's do else if we know year, if year is divided by 4, year is divided by 4, but year is not divided by 100, then we know it will be 29. And we say year not divided by 100 not equal to 0. It's not a century. Or year is divided by 400. Okay, for example 2000 is divided by 400. Year divided by 400 equal to 0. Then we will return 29. Okay, else it will be 28. So only case we will get 29 is when this condition is met. Like year is divided by 4, it's a leap year, but it's not a century. Year is leap year, but it's not a century. Or year is leap year and it is also divided by 400. Then it will be 29, otherwise it will be 28. That's what was explained in this text here. So that should give us our count days. Okay, so let's quickly test it. Number of days of month. Let's see, if I give February and then I give year 2000, then it will be 29. But if I give 1900, it will be 28. If I give 1600, it will be 29. But 1700, 28. Okay. And if I give 1704, that is 29. Because this is not a century and it is a leap. So you get the point. Okay. Now our problem is asking us to count the Sunday. Okay. There's one thing we have to consider here. It says that 1st Jan of 1900 was Monday. 1st Jan of 1900 was in Monday. So if we just do it like that, if we just say 0 is equal to Sunday, okay, Sunday, 1 is equal to Monday, 2 is equal to Tuesday, just like that, 3 is equal to Wednesday. So if we consider like that, and we have to count the Sundays, right? If we have to count the Sundays, that means our day count position should be 0. Now because the 1st January of 1900, 1st Jan of 1900 was Monday, which is day position is 1. Then let's find out what is the 1st Jan of 1901, because that's where we are starting. So 1st Jan of 1901 will be, because 1900 is a century, so that's why we have February will become 28 days. Okay, so that means the total number of, it's going to be 365 days for this year. It's not 365, not 366. Okay, not 366. And if you just divide 365, just if you just do modular divide 365, okay, it's not 365, then it becomes 1. That means there's 1 day extra. So that means if the Monday of 1900 was Monday, sorry, if the first Jan of 1900 was Monday, then the first Jan of 1901 will be Tuesday. First Jan of 1901 will be Tuesday. And which means the position will be 2. Okay, position should be 2. That's what we want to know. Now I'm just writing a loop. I say current day. Current day is equal to 2 because that's where we are starting. We're starting with 1st Jan of 1901. So I'll start with current day is equal to. Then I'll have a count variable. Count is equal to 0. Now I'm just trying to create a number. Now remember that because it's a century, right? That means there will be 100 years, and 100 years will have, each year has 12 months, so there will be 1200 months. I'm just using that calculation for our simplification. For num in range 1 to 1200, okay, because I want to start month as 1, not as 0. Now what will be my month? Current month will be this number modular division 12 plus 1. This is going to be my current month. And what is going to be my previous month? So previous month is equal to current month minus 1. Simple as that. However, if we do that, you see we started month is equal to 1, and if we just minus it minus 1, it may become 0, and there is nothing called 0 month. So in that case, we'll have to write this condition: if previous month equal to 0, that means previous month is actually equal to 12 because it's December for the previous year. Now let's try to find out the year. What will be our year as we move along? Remember we are starting with 0, 1, and then year should be num integer division 12. That should be our year. Now what is going to be our current day? Current day is equal to, okay, so basically in current day meaning we are trying to keep track of the first of every month. Okay, and so basically we'll just moving forward in 1 month. That's why I have taken 1 to 1200. That means for every number we increment, we are moving 1 month in advance. So that means the current day is going to be the first of every month. So that will be current day of previous month plus get the number of days of previous month. Okay, because current day of previous month was first of day. That means it was first, let's say 1st of January 1901 was Monday. Okay, and it was Monday meaning the day was 1. Then I want to find out what will be the 1st of February of 1901. That will be get month of the days for the current one. That means it will be 1 plus 32. Sorry, 1 plus 31. 31, since 31 is the number of days of January 1901. So current day should become like 32. Okay, so just like that. So then that's why I want to create. I'm in February, and I want to get the previous month, number of days of previous month, and the year. Okay? So that should be our current day. Now I want to do it like if current day modular division 7 equal to 0, that means this is a Sunday, and then I want to increment our count because we got one Sunday. Okay, now if I just run it, and if I just have a look at our count, see it's 171. So I hope this is clear. So let me try to explain once again. So because the question is asking how many Sundays are there for first of every month, and how many months we have total 1200, and we are moving forward for every month. For every month I want to find out what is the current month positions. Is it January, February, or March? What is the previous month position? Then what is the days of the current day? Okay, if you look at that current day, basically current day will increase. Okay, it will increase. But if current day is modular division 7 is equal to 0, that means it is a Sunday. So that's why our count is 171. So let's check it out if this is working. 171. Yeah, looks like this is correct. Okay, thanks for watching. Coming up next is problem number 20. Thanks again.